One question I get from teachers all the time is, why do kids not remember the mathematics from last month, a year ago, 5 years ago? It's always a big question. And so we're going to talk about that in today's research overview. I'm Dr. Jonathan Brennifer from the Developing Mathematical Institute, and my focus for my doctorate was cognitive psychology and mathematics. So we're studying the importance of the brain. So we're going to talk about why kids forget, and then what should we be doing to make sure they don't forget ideas. Okay, so we start with the idea of the working memory. So that's what we're thinking about right now. So we could be thinking about if we're cold or hot, how our hands, our feet feel, what people are saying, what we're looking at. Kids' attention can go all over the place. We want to focus that because with working memory, you only can focus on 3 to 7 chunks of information at a time. Now I use the word chunks because that's important. It's not just 7 ideas or 7 items. You can actually chunk 3 to 7 items within each chunk. So you can actually multiply the number of ideas that you have while you're focusing on your working memory. So with our working memory, the next idea is to get it into long-term memory. We want to put it into long-term memory, and that is a really important idea. So when we just focus on procedures or memorization, rote ideas, it's going to go somewhere, we hope, into long-term memory, but is it attached to anything? That's the important idea that we have to focus on, is getting kids to lodge those ideas, those chunks of information, into a schema. So a schema is a set of information. I think of it like a spider's web. It has multiple connections to other ideas. And we want to have as many connected ideas on any given topic, because that helps us to not forget things. It helps us remember things long term. So the greater your schema, the more connections you have, the greater your memory, and the greater chance you'll be able to problem solve and remember it long term. Okay, to do that, we're going to start with Bruner's ideas from the 1960s. He's a cognitive psychologist, and we have another research overview if you want to read more details about him and his ideas. But he talks about, we want concrete and active physical models first, getting kids to play with things, and then moving, really importantly, to iconic, a visual model. In mathematics, again, diagrams, number lines, bar models, area models, things like that are really important because that actually helps us chunk the information. Our visual memory is so powerful that really helps us for long-term memory. And a lot of times we skip that. So that's a really important idea. We also have a research overview on that if you want to read more. And then third, now we move into the abstract symbolic models. So that is our equations and our algorithms and tables. And so to get there, you have to have the other two to build a deeper representation. Now, some kids will just do that themselves naturally. They're playing with things at home. The parents have games, different sports that they're playing. Awesome. But if kids aren't getting a lot of those experiences or aren't making the connections, the schemas aren't connecting, and that's what we have to do. The next thing is we're going to think about Ausubel's meaningful learning. So Ausubel talked about you have to generate meaning around that concept. And a lot of times we don't do that. We just teach the mathematics and we then have some story problems at the end. That's not good enough. We actually should start, I like to start ratio proportion 6th grade with a big topic of the Great Wall of China. So you can show pictures of that. You have the kids going, oh, wow, that's a massive wall. And you can say, notice on the wall that there's towers. The towers are as far as you can see. That's about 3/4 of a mile. Why do they do that? Well, back in the day, they didn't have cell phones, so they would show smoke. They'd have fire, and if you saw smoke, you knew there was a problem over there, and we need to go help. So now we could say, well, if we have one brick, and then that one brick, and we're going to have it 12 feet high, we're going to have it 3/4 of a mile long, how many bricks do we need just in that one section? Now, we're going to have from tower to tower to tower. We're going to think about proportion. We're going to be building that, and that a multiplicative idea of we're going to be multiplying it. 1 million bricks for this tower, be 2 million for 2. What about for 10? What about for 15? And it's absolutely astounding how long the Great Wall of China is. So all those things play into the unit. So then when kids a year later are going, oh, ratio proportion, their schema is like, oh, we started that with the Great Wall of China. And so now everything allows them to make those connections and then remember it and then use it for new situations that are slightly different. So that's really important to get those ideas into long-term memory. So again, having those different representations, the inactive, iconic, symbolic, having visualization, really key, and then making it meaningful. So having even a month-long theme is really powerful. Okay, again, this daily lessons, we should always start with a warm-up that is possibly a connection to what we're going to be talking about, and so that they can connect it back in their own schema. So once you engage that, that gets the engines running for them, which will help them pay attention more and remember more. And then end the day also with an exit ticket. Have them end with, oh yeah, so today I am remembering what? What are they walking away with? That's really important, that they start the day with something and they end the day with something. So I named a number of different research overviews. You can check those out on our website, dmtinstitute.com. I'm sure you like this, so go ahead and share it with other people, and please follow us and like us.